there. In this video we're going to learn about quadratic functions. We're going to learn what is a quadratic function and how to draw them. They have the equation y equals ax squared plus q. The x squared is what tells us that this is a quadratic function. So we need to learn about what a and q do as values. But let's start by sketching through coordinates and understanding the shape. So suppose we want to sketch the graph of y equals x squared minus 4. We don't know what this looks like, so let's start with a table of numbers and work out the y values. To do so, we'll take x equals negative 3 and substitute the negative 3 into the x, and we will square it and subtract 4. Now the negative goes into the bracket with the 3 because it is part of the number. So negative 3 squared is 9 and 9 minus 4 is 5. So the y value is 5. You can work out the other ones if you feel confident. If not, carry on working with me. Let's substitute negative 2 into the x. We'll get negative 2 squared, which is 4, and 4 minus 4 is 0. Let's substitute negative 1 into x. We'll get negative 1 squared, which is 1, and 1 minus 4 is negative 3. Maybe you can try the rest now. I got negative 4, negative 3, 0, and 5. I'm going to take that table and convert the ordered pairs into a set of coordinates now. So x is first, then y, minus 3, 5, and make all your coordinates. Now I'm going to plot my coordinates on a graph. So the point minus 3, 5 is up there. Maybe you can plot the rest of the points that you've worked out. I'm going to quickly do that. We've been plotting points for a while now, so it shouldn't be too difficult for you. Remember, x is first, then y. So we go across to x at 2, and then we don't move up or down because it's 0. Okay, and there we've got some points, 7 of them. But we can see that they're not a straight line. The question is, how do we join them? We don't join them with straight pieces from one point to the other. Some people join them with rulers like that. That is wrong. It is one graph, not a set of straight lines joining each other. So instead of that, we join them with a slightly curved, free-flowing movement that makes one shape. And this is a quadratic function or a parabola. It is one that is opening upwards because as you move up, it gets wider. Now let's look at this one. We're going to follow the same process. So maybe you want to pause and do this yourself. Table, x values. Pause and try on your own whenever you feel ready to do that. So I'm going to take my minus x squared plus 4 and I'm going to substitute minus 3 into the x. The minus is outside the bracket because it is in the formula. This minus is inside the bracket because it is a negative number. So I'm going to first work with BODMAS brackets first. Minus 3 squared, we do exponents before timesing, and I will get minus 9 plus 4 is negative 5. Okay, try the other numbers. You will get 0. Again, more negatives, but the number is smaller than the add number, so it's a positive number. Keep going and work out all your numbers. There we go. Let's make them into coordinates. We've got all our coordinates now, and let's plot these points. Okay, so we've got negative 3 and negative 5 down here. And as we go through our points, we plot them all. And we notice that this shape is different from the last shape, but not terribly different. It's just the quadratic function or parabola upside down. So we've learned a few things here, and let's summarize it. There's an a value and a q value, and they do different things. You might have figured out what they do. If not, let's figure it out. So we've drawn graphs that open upwards and graphs that open downwards. So the shape of knowing whether it opens up or opens down is important, and that is determined by your a value. If your a value is positive, it will open up, and if your a value is negative, it will open down. Okay. To draw these graphs in future, we're going to get the shape. We're going to get the y-intercept by setting x equal to 0, which tells you that q is your y-intercept. Then we're going to work out x-intercepts by setting y equal to 0, and difference of squares will give us our answer. If we have a graph that turns on the x-axis or has no x-intercepts, then we can't do this. And so we choose another value for x and we work out the y value that matches. And due to symmetry, because the graphs are the same on both sides, we'll get the same y value at -1, and we'll draw the graphs that way.